This is Dust Desired, an open source, adaption encouraged recipe and process that allows anyone, anywhere to create useful materials from waste sawdust. It was born from a desire to do the best with any given material and an interest and exploration of wood recycling processes. The process takes waste sawdust from CNC workshops, combines it with dry ingredients like pine rosin, agar and cornstarch, cooks up the mixture and compresses it in moulds to create blocks of material. This process has been developed through numerous experiments and is still being developed.
It's also just a reminder that when you're working in the umbrella of sustainability, nothing happens quickly. It's about really doing it slowly and getting it right, and just taking your time with it.
The process began by engaging with local wood recycling operations, learning about their limitations, and as a result, experimenting with unrecyclable, contaminated wood. A key insight of these experiments was the use of epoxy resin. Although it didn't fit with the idea of using the best of any material, it did produce very interesting results, and the decision was made to find more natural alternatives like pine rosin and wax. At the same time, the source of contaminated wood was running out, but I had just been given wood shavings and sawdust from a wood turner that were destined for the bin. I experimented with combining the sawdust and shaving with the wax and rosin to create interesting forms and develop a technique. An issue I had was that these forms were mostly decorative, and I felt that being able to show a functionality would result in a more viable material. To achieve functionality, I sought out consistency. With the help of cutting-edge CNC, I was able to source sawdust from CNC machines. This sawdust was extracted straight from the tool head, making it a consistent size and type. It was also a consistent supply, almost 80 litres per day. With this new supply and a new mould that produced consistent blocks, I began experimenting, trying to make a material that could be machined. The ultimate goal was to produce a material that could be returned to the CNC machine to provide circularity to the process. These machining tests taught me a lot about the aspects of the material recipe that did and didn't work. In particular, high rosin content was causing the material to melt and clog the tool heads. To remedy this, I looked at other open source recipes and used other natural ingredients to bond the sawdust and reduce the amount of rosin. I also worked in larger batches and produced sheets that were suitable for CNCing. The initial CNC tests highlighted issues with the strength of the material, but adjustments to the CAD file and control of the machine produced some successful results.
So yeah, I think it's great that you're thinking about the consistency of the material. So if you want it to be something that's circular and goes back into the process, then it's probably, it's important that the consistency is right with it all. And if you're ever going to think about if there's potential to upscale it and offer it as a standard sheet material, then obviously the consistency within it will be quite a big thing to consider. I think it definitely sounds like you're in a good stage with it, and you could probably get some kind of funding to develop after uni. I think you probably definitely get funding for something like this.
The future ambition of the project is to refine the process and have more control over the variables, with the aim of producing a more viable material. An important consideration is that by introducing more complexity to the process and reliance on specific machinery, the replicability of the project and the circular and distributed nature of it may become reduced. This is a balancing act that will continually need to be managed.